I was woken up in the middle of the night by a thud on the hull of our boat. And we rushed up on deck, and we found that we were surrounded by pieces of plastic in the ocean. We were over 1,000 miles from nearest land. In fact, the closest people to us were in the space station in orbit above our heads. And yet, there was evidence of human life and waste all around us in one of the most remote parts of our planet. Now, at this time, I was on a journey around the world on this crazy biofueled rocket ship called Earthrace. And we were on a campaign to promote renewable fuels. But really, for me, it was a way to hitchhike from England to a new job in Australia without taking an aeroplane. And it was on this journey 8 years ago that I saw the changes that were happening in the ocean, and it took me off in an entirely different direction. And so we would stop at these small islands, and we would find that the locals could no longer catch fish to feed their families because of the commercial fishing vessels that had caused the fisheries to then collapse. And they were no longer able to grow food because the sea level rise had caused their soil to become too salty. And the knock-on effect of this was a new reliance on this packaged food and drink that's imported from overseas, but of course comes wrapped up in this new weird material called plastic. And there's no system in place to deal with that material, so it often gets dumped in the ocean, on the beach, and also burned. And it was that smell of burning plastic that kept getting up my nose. And when I learnt more about it, I found out about these chemicals, these dioxins, that are released through incomplete combustion of waste, and the fact that they are carcinogens that can get absorbed into our body. And so this became my mission. How do we eliminate the burning of plastic across this group of islands in Tonga, in the heart of the South Pacific? And at first, it needed to start with a shift in mindset. As I started to learn the Tongan language, I realized that there wasn't a word for rubbish or for bin. And that idea of throwing something away in a controlled manner didn't exist in their culture because until really recently, it hadn't needed to, because a banana peel and a coconut husk can happily just lie on the ground. And so, after 6 months of working with the local communities, it culminated in an enormous cleanup, where together with 3,000 local volunteers, we picked up 56 tons of rubbish in just 5 hours. Now, this amount of waste just totally overwhelmed me, and not only the waste that was coming from the local community, but also every day when I walked along that beach and I saw another piece of plastic land on the shoreline, often with writing on it in languages that I didn't recognize. And I wanted to know, what was all this plastic doing out there? Where was it coming from? And why was it ending up on this little beach in Tonga? And so I started to learn more about this concept of plastic, where it came from, and what it is that we do. And it turns out that we use 60,000 plastic bags globally every 3 seconds. And those bags, they get used once, maybe twice, probably 3 times at best, and then they're thrown away. And the thing about plastic is it's this amazing material, and it's amazing because it's designed to last forever and ever. And then we go and make things like plastic bags and other disposable packaging that's designed to be used just once and then thrown away. And it's that mismatch of material science and product design that puts us in the situation of having huge amounts of waste plastic that no longer has any use or value. So I thought, that's all right, can't we just recycle all of that plastic? Can't we just turn it back into new things? But a trip to a recycling centre showed otherwise. Only about 10% of the plastic that we use actually gets recycled. And that number's so low because plastic is really a term that we give to hundreds of different materials. They all have different properties, and to give them those properties, they need different chemical structures. But when you recycle something, the first thing you have to do is separate out all those different types of plastic. You need to clean them, and it's a very lengthy and expensive process. And it's much, much cheaper to take virgin plastic and make new products from scratch. And so, instead, we see a lot of this plastic going to landfill, and also 8 million tons of it annually washing down streams, down rivers and waterways, and eventually everything runs downhill to the ocean. In fact, this video here was taken 6 months ago in Lombok, Indonesia, about a half mile upstream from the ocean. When it gets out there, then what happens? It meets these ocean currents. Because of our planet spinning, the Coriolis effect has these big rotating system of currents that pulls the plastic into the centers of our oceans. And those are what we call the 5 subtropical oceanic gyres. And so this really became the next mission, to go out and see what was there in these accumulation zones. At this point, it was all theoretical, but how much waste were we going to find? Could we perhaps bring it all back to land, recycle some of it, do something with it? We really didn't know. And so we got a team together on the Sea Dragon expedition vessel and set off in search of these islands. Islands we didn't find. There weren't these areas of rafted together plastic. We just saw one piece here, one piece there, as I'd seen on that trip on Earthrace. And it wasn't until we put a fine net through the water that we realized that the bigger problem was actually the smaller pieces. Because when we bring that net back on deck, turn that sock inside out, this is what we find. We find thousands of tiny fragments of plastic, smaller than your little fingernail, what we call microplastics. And most of the plastic in our ocean is actually that big. When we get these samples on board, we see the same thing all the way from the tropics up to the Arctic, and it's almost like there's this fine mist of plastic pieces that just vary in concentration across our whole ocean. And so when we get those samples back on board, the next thing we have to do is analyze them and work out what's plastic and what's plankton. And it took us a while to realize in this sample that those 2 fragments there were actually plastic. And it made me wonder how the fish would cope working out what was their food and what wasn't. And then we start finding things like this fish with actually fragments of plastic inside its stomach. And so this is when the conversation started to change, because we were no longer just looking for the physical presence of plastic in our ocean, but we were also then curious about what are the chemical implications. If plastic, which has these toxics in it, is getting into fish, and we are in the same food chain that that fish is at the bottom of, then what might that mean for us? And a lot of this plastic either has chemicals in it or absorbs other persistent organic pollutants that are in the water. Things like pesticides or flame retardants that are on our clothes and on our upholstery, or fluorinated compounds that we use for waterproofing our camping gear and for making the inside of our frying pans non-stick. There's all these really useful chemicals that we love to use, but at the end of their use, they're a pollutant. And they have a property that makes them persistent. And so they will biomagnify up that food chain. And so a couple of years ago, I wanted to know, is this something that we really needed to worry about? Or was this just a theory and all, not actually proven? And so I decided to have my body tested to find out what toxic chemicals I have inside me. So worked together with the United Nations, we picked 35 chemicals that are known to be toxic to humans, and they're also banned by the UN. Of those 35 chemicals that we tested for, we found 29 of them inside my body. So this is when things really changed for me. And I often find that when we hear about things about the environment that we maybe see on the news, it's about something that's happening somewhere else to somebody else at some point in the future. But knowing that I have these chemicals inside me, and I'm afraid we all do, you do too, makes it really hit home. And so we put together a project called Expedition, which is a series of all women's voyages around the world to delve further into this issue of toxics. So on doing a bit more research into what these chemicals might do, I learned about carcinogens and also endocrine disruptors that mimic our hormones and particularly affect fertility and reproduction in the female body. And while the chemicals, the levels that I have inside me, are not alarmingly high, that I need to be immediately concerned about my health, it's a really scary indicator of the direction that our society and the health of our environment is going, and a way that we really do not to be headed. So if we take that idea of using the body as an indicator for the health of the environment, we set up this project to explore that further. All of us girls had our body burden tested and found some interesting results. One of our crew members from California found she had very high levels of flame retardants inside her. And interestingly, California has one of the highest use of flame retardants in that state than anywhere in the world. Another one of our crew members had very high levels of mercury after spending 6 months living in the Amazon, eating fish downstream of a place where mining was taking place that uses a lot of mercury. And these results show that probably there is a link between our environment and the health and the levels of toxics inside us. But to move on to a slightly more positive result, we also looked at DDE, which is a derivative of DDT, a chemical that was used to control malaria a lot in the 60s and banned in 1972 after the realization of the effect it was having on the bald eagle. You can see here that one of our crew members has off-the-chart levels. That red patch is the sort of average zone, and the rest of us right down at the bottom. Now, interestingly, Sue was our oldest crew member. She was 67 years old, and the only one of us who was alive before 1972. And so this really does prove that we can create change. If we make a ban, then we can see the results. And if we have that inclination, we can solve this. We can create change, and we literally see the results in our own bodies. And what if we got CEOs, politicians, if all of us, if we could see our results, if we could see our children's results, would we then have governments that form the policies that we need, have corporations design the solutions to these problems? And would you and I make those smart choices that we need to make about the things that we use and we buy? And it makes me realize that it took for me to actually see the real impact that the environment was having on me before I actually realized to the magnitude that I needed to act. And I think that if we can make something visible, if we can make the unseen seen, then it will give us the propulsion that we need to really create change. Thank you.